to yet another video on our channel Euclid Mathematics. In my today's video, I will explain to you all one of the question which is from relation and function chapter, where the value which is lying. Okay, so now let's get started our today's example. I will explain to you all how the example look like. Let's read the question. So here question number 38, it says that function is given f of x as x upon x square plus 1, which is an increasing function. Then we want the value for x, okay? So where that x lies, okay? So we have to find out the range of a value of x, okay? Where that value x is lying, okay? So here first option it says that x taking whole value from real, r means real number, okay? So this r is represent capital R, which is a real number. So x lies on whole real number. Now second option it is given under open interval negative infinity to negative 1. So that means all negative value for x which lies from negative infinity to negative 1, okay? Now third option it is the only positive value, so which is under open interval, again open interval 1 to open interval infinity, okay? And now third option it is here, so open interval negative 1 to 1, okay? So that means open interval means the value which is here in a boundary, these are not considered here for the value of x, okay? So the between value for 1 and infinity which is considered for x, okay? So we have to figure it out which one of the option is correct for our value of x, okay? Now let's get start our today's solution. I will explain to you all how the solution look like. Example, f of x is given x upon x square plus 1, okay? So we have to find out the value for x where x is lying, okay? Now f dash of x, so we have given, why we have to find f dash of x? We have given f is increasing, and when function is increasing, that time we have to apply the rule for maxima minima, okay? So function is increasing, that means the f dash of x which is strictly bigger than 0, okay? So apply this rule here. So f dash of x, which means we have to apply quotient rule of a differentiation for finding the differentiation of f dash of x, okay? So quotient of a differentiation, quotient rule for differentiation, it says that differentiation of a u upon phi can be written as phi into differentiation of a u. So phi as it is, differentiation of u is 1, x with respect to x is 1, and negative of u into differentiation of phi. So x as it is and differentiation of v. So x square is a 2x and 1 is, it is a constant, okay? It means it's 0. And v square, that means x square plus 1 bracket square, okay? So go for simplification of steps here. So x square plus 1 multiplied by 1. So x square plus 1 minus x into 2x, which is a 2x square, okay? X square plus 1 minus 2x square upon denominator x square plus 1 bracket square, it remains same, okay? Now go for further calculation. So x square minus 2x square, which comes as a negative x square. So 1 minus negative x square upon denominator as it is. And as we have our function which is increasing, so if f of x is increasing, then we write f dash of x, okay? F dash of x which is bigger than 0. That means the value for f dash of x we found here, that is strictly bigger than 0. So I represent this one is here. 1 minus x square upon x square plus 1 bracket square, which is bigger than 0, okay? So this value is bigger than 0. That means if a denominator, if we take it here, it goes to the multiplicand of 0, then that means it goes to 0. So 1 minus x square, which strictly bigger 0, okay? So 1 minus x square, which is bigger than 0, means x square, take that negative x square, it is here. So negative x square, it gets here 0 plus x square. That means x square is smaller than 1, okay? So here we can observe what is the value possible for x when it is smaller than 1. But x square means x is a positive here, okay? That means x lies between the two values, which is a positive 1 and negative 1. So we know that if negative x we take, it square it comes positive x, and positive x square it comes also positive x. That means the value for x which is smaller than 1, but it is a square, it is there. That's why it is smaller than 1 but bigger than negative 1, okay? So bigger than negative and smaller than 1. The value which is possible for x which lies between negative 1 and 1. So that means x has a smaller value negative 1 and bigger value which is 1, okay? That means this is strictly less sign represent it is having open interval, okay? That means x which is lies between negative 1 and positive 1. So our correct option is a D, where x lies between negative 1 and positive 1, okay? So it's quite easy answer. We just have to apply the differentiation rule for increasing function and then find out the range of our value of x, okay? So I hope so you all have understood my today's lecture. It's quite easy. Just we have to apply result from function chapter and differentiation of an increasing function. Then it's easier to find out the value of x. Okay. So thank you everyone. Thank you for my today's lecture.